don't have to take those supplements. You just have to dim the lights. It'll stimulate the natural melatonin production of your body.
Who are you?
Oh, I'm Penny, your pineal gland.
And why are you in my bedroom?
I'm not in your room. I'm in your brain.
That seems worse.
Melatonin production is kind of my thing. When you get drowsy, that's me, getting to work. Since you've been taking those supplements, I haven't had much to do, so thought I'd hang out here. Oh, aren't we looking dapper?
Great! I haven't slept in days, and now I'm insane.
Oh, don't be silly. You're just having insomnia-induced hallucination.
Is that any better?
Oh, relax. A good night's sleep will clear this whole hallucination business right up.
Well then, looks like I'm stuck with you. I haven't had one of those in a while.
Well, I might be able to help, but, in exchange, no more melatonin pills. You're great company and all, but I want my job back.
Deal.
All right, let's go.
Where are we?
In your brain.
Where are we going?
Well, there are many areas that could be responsible for your insomnia. Sleep seems like a simple process, but it's not. And there are many mechanisms and controls. Each night's sleep can be split up into several 90-minute cycles, consisting of 5 stages. Stage 1 is that drowsy feeling when you're on the edge of falling asleep. Stage 2 is when you enter light sleep, and stage 3 and 4 are the deepest levels of sleep. These 4 cycles can be put together to be the majority of your sleep. Neurons fire slower.
Okay, so what about the 5th stage?
Well, that's REM sleep, or rapid eye movement. As opposed to the other 4 stages, your brain actually becomes more active. Almost as active as if you were awake, which has earned it the name paradoxical sleep. You only spend an average of about 15 minutes in REM per cycle, but that time increases with each progressive cycle.
If I'm asleep, why would my brain activity increase?
We'll get there. Look, this is our first stop. This is the suprachiasmatic nucleus, or SCN. It's the master clock of the brain. It controls the time and length of your sleep cycle.
How does it know what time it is? The position of the sun or something?
Cells in the SCN make a protein called PER. PER is a protein that inhibits its own synthesis. This means that when levels of PER protein rise, the production of PER falls. And when PER levels fall, production rises. The result is a cycle that repeats about every 25 hours, and we call it the circadian rhythm. The circadian rhythm is used to regulate metabolism as well as sleep.
But what does the sun have to do with it?
Well, the PER cycle is 25 hours, and a day is only 24 hours. So you need a system to account for the difference. Photoreceptors in your eyes respond to light and send signals to the SCN to increase the production rate of PER in a process called entrainment. When you feel drowsier at night, that's due to the increased PER production.
So, how's my SCN doing?
Actually, it seems fine.
Is that my brain?
Yep.
I thought we were in my
Our
brain.
next stop should be right here.
How?
Oh, come on.
Oh, wow. This is beautiful.
Welcome to the reticular activating system. If the SCN is the master clock of the brain, this is the master switch. It controls the transition between wakefulness and sleep.
How does it do that?
When the neurons of the reticular activating system fire, they inhibit neurons in the thalamus, an important cerebral structure that connects the cortex, or the conscious part of your brain, with the rest of your body. Essentially, it connects your mind to the outside world. The thalamus is naturally in a chaotic bursting state, where it disconnects the cortex from the rest of the body and occurs when you are asleep. But when neurons from the RAS stimulate the thalamus, it enters an active state, which allows impulses to reach the cortex, connecting it to the outside world and stimulating wakefulness. Don't do that.
Sorry. So, if this is the cause of my insomnia, then wouldn't it be a lot more active?
It would be, but it isn't.
My SCN is fine, and my reticular activating system looks okay. What's been keeping me awake? Oh,
Oh no.
what is this? Is this the active state?
No, it looks like your brain's booting into REM sleep. But this may be what we're looking for.
Where are we going?
We're going up.
Where are we?
See for yourself.
College?
Nope. This is the forebrain. It's a seat of consciousness. The SCN and RAS are involuntary systems. This isn't. This is the place that defines who you are.
Okay, so what are we supposed to do here? Is there a clock we need to reset or wiring to fix?
Well, REM sleep is an enigma. No one knows much about it other than the fact that it's essential for life. I mean, newborns spend nearly all their sleeping hours in REM, but you require less and less of it as you age.
What does it do?
Well, there are a few proposed functions. The first being that it strengthens memories, especially emotional ones, converting them from short-term memories to permanent long-term ones. Some think that your brain runs simulations, your dreams, the similar way that a school runs fire drills. If you ever find yourself in a similar situation, you'll know exactly what to do. A third proposed function is that REM is used for unlearning.
Unlearning? You mean like forgetting?
Sort of. We think it's how you cope with what happens during waking hours. Every moment you are awake, your neurons are firing, gathering information and forming memories. There's simply not enough storage space to keep all of it. Also, forming memories strengthens neural connections. But if these connections are continuously strengthened, overexcitation of neurons may lead to cell death and seizures. The unlearning theory posits that during REM, the brain fires randomly to weaken synaptic connections. Basically, you dream to forget.
But all that stuff doesn't explain why I can't sleep.
Or maybe it does. A common thread of all these theories is that REM helps your brain digest what happens in your waking life. If you're going through something stressful or maybe traumatic, it can be too much for your mind to handle. The human mind is the most complex thing on this planet, and no one understands it.
No way. I mean, aside from the insomnia, my psyche is totally fine.
Then why are we walking around an empty campus?
I don't know.
Part of you does.
Penny! Wait! Penny! Penny, wait! Penny! Who are you? Wait, no, stop! Penny, help! No! Come on! Don't! Let me back in!
You're gonna be alright.
Penny, come on. Let me back in. You're supposed to be telling me what's been keeping me awake.
Well, it seems like you figured that out by yourself. Graduating college is a pretty big deal. I'm not surprised you're stressed.
Well, what do I do about it?
I don't know about that. That's way out of my jurisdiction. Waking up would be a start.
What if I'm not ready to wake up?